Hi everyone, so for this moment, I will tackle the sounds and its properties on the layers of the earth. So, let's go!
What is sounds and its properties? How about the layers of the earth? Sounds waves. Why does a tree make sounds when it crashes to the ground? How does the sound reach people's ears if they happen to be in the forest? And in general, how do sounds get started and how do they travel? How sounds begin? All sounds begin with vibrating matter. It could be the ground vibrating when a tree comes crashing down, or it could be a guitar string vibrating when they are plucked. You can see a guitar string vibrating in the figure below. The vibrating string repeatedly pushes against the air particles next to it. The pressure of the vibrating string causes these air particles to vibrate. The air particles ultimately push together and spread apart. This starts waves of vibrations that travel through the air in all directions away from the string. The vibrations pass through the air as longitudinal waves, with individual air particles vibrating back and forth in the same directions that the waves travel. Sound waves travel through air in much the same way as water waves travel through water. In fact, since water waves are easy to see and understand, they are often used as an analogy to illustrate how sound waves behave. Waves can travel through many different kinds of matter. Most of the sounds we hear travel through air, but sounds can also travel through liquids such as water and solids, such as glass and metal. If you swim underwater or even submerge your ears in bath water, any sounds you hear have traveled through your ears through water. You can tell the sounds travel through glass and other solids because you can hear loud outdoor sounds such as sirens through closed windows and doors. Speed of sound. The speed of sounds is the distance that sound waves travel in a given amount of time. You probably already know that sound travels more slowly than light. That's why you usually see the flash of lightning before you hear the boom of thunder. However, the speed of sound isn't constant. It varies depending on the medium of the sound waves. Table below lists the speed of sound in several different media. Generally, sound waves travel faster through solids and slowest through gases. That's because the particles of solids are close together and can quickly pass energy of vibrations nearby particles. Sounds. It is a form of energy produced by a vibrating body. Sounds requires a material medium for its propagation, then sounds does not propagate in vacuum as there is no material in the vacuum. The to and fro or back and forth motion of an object is called vibration. Some instruments produce sounds due to the vibrations of membranes, some due to the vibrations of strings, and some others produce. Pitch. The pitch of sounds depends on its frequency. If frequency is more, then the pitch of shrillness is more. The pitch of a woman's voice is more, and it is shriller than a man's voice. Example of low-pitch sounds are animal roar, guitar sound, a large bell, and thunder. High pitch, nails scratching on blackboard, school bell, whistle, rubber shoes squeaking against a basketball court, then fireworks. The audible sounds. Not all sounds produced by vibrating bodies is audible. The human ear can recognize sounds of frequencies in the range of 20 Hz to 20,000 Hz. This range of frequency sounds is called the audible sound. Some animals like dogs and snakes can hear sounds of frequencies greater than 20,000 Hz. Example, drums, guitar string, and tuning fork. Infrasonic sounds. Sounds of frequencies less than 20 Hz are called infrasonic sounds. Examples, humans cannot detect it. Sound produced by earthquake, volcanic eruption, and ocean waves. Weather. Lee waves, avalanche, waterfalls, meteors, lightning, and etc. Ultrasonic sounds, the sounds of frequencies greater than 20,000 Hz, are called ultrasonic sounds. Examples: a dog whistle that cannot be heard by humans. An example of ultrasonics is the detections of ships and objects underwater by bouncing a high-frequency sounds wave of their hulls. Layers of the Earth. The structures of the Earth is divided into four major components: the crust, the mantle, the outer core, and the inner core. Each layer has a unique chemical composition, physical state, and can impact life on Earth's surface. Movement in the mantle caused by vibrations in heat from the core cause the plates to shift, which can cause earthquakes and volcanic eruptions. These natural hazards then change our landscape and in some cases threaten lives and property. Learn more about how the Earth is constructed with these classroom resources. Cross-sections of Earth showing the following layers. Atmosphere. Earth's atmosphere has 5 major and several secondary layers. From lowest to highest, the major layers are the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Continental crust is the outermost layer of the Earth's lithosphere that makes up and planets, continents, and continental shelves and is formed near subduction zones, plate boundaries between continental and oceanic tectonic plates. Ocean crust. Oceanic crust is the uppermost layer of the oceanic portion of the tectonic plates. It is composed of the upper oceanic crust with lavas and a dike complex and the lower oceanic crust, composed of troctolite, gabbro, and ultramafic accumulates. The crust overlies the solidified and uppermost layer of the mantle. Upper mantle. The upper mantle of Earth is a very thick layer of rock inside the planet, which begins just beneath the crust and ends at the top of the lower mantle at 672 km. Temperatures range from approximately 200 degrees Celsius at the upper boundary with the crust to approximately 900 degrees Celsius at the boundary with the lower mantle. Crust. Earth crust is a thin shell on the outer sides of Earth, accounting for less than 1% of Earth's volume. It is the top component of the lithosphere, a division of Earth's layers that includes the crust and the upper part of the mantle. It is the outermost layer of the Earth's surface. Mantle Earth is a mantle that have a layer of silicate rock between the crust and the outer core. It has a mass of 4.01 by 1024 kg and thus makes up 67% of the mass of Earth. It has a thickness 2,900 km, making up about 84 degrees of Earth's volume. It is the layer that lies below the crust. Lithosphere. The lithosphere contains oceanic and continental crust that varies in age and thickness across locations and geologic time. The lithosphere is the coldest layers of the Earth in terms of temperature, with the heat from the lower layers generating to plate movement. Asthenosphere. The asthenosphere is the denser, weaker layer beneath the lithosphere mantle. It lies between about 100 kilometers to 62 miles and 410 kilometers to 255 miles beneath Earth's surface. The temperature and pressure of the asthenosphere are so high that rocks soften and partly melt, becoming semi-molten. Outer core. Earth's outer core is fluid layer about 2,260 km thick, composed of mostly iron and nickel that lies above Earth's solid inner core and below is mantle. Inner core. Earth's inner core is the innermost geologic layer of planet Earth. It is primarily a solid ball with a radius of about 1,220 km, which is about 20% of Earth's radius or 70% of the Mons radius. There are no samples of Earth's core accessible for direct measurement, as there are for Earth's mantle. Thank you for watching!